Here, the question is, a pump on the ground floor of a building can pump water to fill tank of volume 30 meter cube in 15 minutes. If tank is 40 meter above ground and efficiency of pump is 30%, electrical power consumed by pump is what? Right? So it's like that. Suppose this is a pump. Okay, this is a pump which is pulling water from the ground, and just here is a tank, right? If this is a tank and this pump is filling this tank, right? Filling this tank. Now we need to calculate the power consumed by this pump, right? So here first you need to understand what is the mass of water, because we will calculate the potential energy or the energy or the work required to fill this tank. That is when the water is lifted up to height h, then it will be equal to mgh, right? Work done will be equal to mgh, right? Now what is the value of mgh? We need to calculate, because water is stored up to height h, so this will be the work. This will be the work. And mass is not known to you. You have given the volume of water is 30 meter cube, so you know that mass by volume is the density, right? So mass of water can be calculated by density into volume, and volume is 30 meter cube, right? This will be multiplied with the density, and density of water is 1000 kg per meter cube, it's known. So it will be 1000 kg per meter cube. This meter cube and meter cube of volume will be cancelled out. So the mass of water will be 3 4 times 0 kg. That means 30,000 kg is the mass of water, right? So use this mass to calculate the potential energy, that is the work done to lift this water up to height h, right? And it's given that tank is 40 meter above ground. So here h equal to 40. H is 40 meter. So work done be calculated as m, put m as 30,000. 30,000 into g. Take the value of g as let's say 10 or 9.8. Take it as original. Into height. What is the height? That is 40. Right? This is the work done which is calculated. Right? Now, this will be in the joule. Now, this is the work done, and we know that it's asking for the power. So, power of a pump is work done per unit time. Right? So, power can be calculated as, just put up the value what we have calculated, 30,000 into 9.8 into 40, this one, divided by time. What is the time? This is 15 minutes, right? So 15 minutes when converted into seconds, it will be 15 into 60 seconds, right? So this is the total power which is consumed. This is in watt. Now just solve it. 60 5 300 00 500, then it will be coming as 9.8 into 40. This will be 500 into 98 into 4. This decimal will be removed, divided by 15. This will give you this much watt. This will give you at 32, 392 into 500 by 15. So this will give you 19,000, 1,96,000 divided by 15. This much of what will be required, but it is asking for the power consumption. So this is not the actual power consumption. So this is, if the actual power consumption, if this actual power consumption is X, let's say X, then this is only the 30%. So 30% of X is the actual power consumption. So 30% of X is this much watt. It is asking for the electrical power consumed by pump. So the value of X will be the actual power. So we can say that actual power consumed, it will be equal to how much? This 100 will come into the numerator. So 196,000 by 15 was your total consumption as required by pump, as used by pump, but here 70% is wasted. So only 30% is this much. So the actual power consumed will be 100 will be coming into the numerator from RHS denominator, and 30 will come into the denominator from RHS numerator, this one. So this will give you the total power consumption, this much watt.